All right, I think we're ready to get started. I'm going to do my best not to hit the up key on this clicker because it's mapped to F5, which in a web-based presentation system refreshes it. So we'll see how that goes. I'm going to talk about DNS today. I've always wanted to sort of give a talk about DNS. I work with a lot of sort of new web developers who know just enough to kind of make their new website work on the new GoDaddy hosting they bought, but they don't really know what's going on behind the scenes. This is very much an introductory session to DNS. I definitely do very much introductory sessions. So I'm not going to talk about some advanced topics. Unfortunately, I missed a comment on my session, which I said I would look at and failed to do that, on some of the advanced DNS attacks and DNS security. There may be some time at the end, and maybe we can have a little roundtable about that stuff. But and really talk about sort of the underlying architecture and kind of how it works, just so you can leave a little bit better informed about how this piece of the internet comes together. That's really kind of an invisible piece that we don't worry about very frequently. Where, as web developers, we kind of need to get the website up, and the website's running, and we kind of worry about DNS at the beginning, and then sort of go away from it a little bit. And that obviously is not the down key. All right, yeah, I'm going to hit that. It's still recording, as far as I know. And I want to share this guy. All right, fantastic. Right back in the game. So a lot of times we hear about some of this different terminology. I kind of want to explain how all those pieces fit together. So there's domain names and registrars. Some people have heard of ICANN or IANA, I-A-N-A. So domain names, what we're talking about are these guys: google.com, redfinsolutions.net, nerdsummit.org. These are your domain names. rfsdev.tk. The domain name system is hierarchical, and it starts all the way at the right and moves to the left, backwards. So these things on the end, com, net, org, tk, these are your generic top-level domains. So these guys, there's a sort of finite list of them, and there's actually been an appeal to add some more of these, and ICANN is listening to public comment about new ones that we should add. Obviously, Google wants to add one called .google, and Apple wants to add one called .apple. And they're taking sort of, ICANN is the organization that sort of oversees all this, and they're very good about listening to public commentary. They're a very international organization. So it's hierarchical, and we backpedal from the top-level domain, the generic top-level domain, the GTLD, into what you're actually buying inside of that space. So there's all the .coms in the world, and then whoever is managing that .com namespace, which happens to be VeriSign, you're saying, hey, inside of that .com space, can I have Google? Is that taken? Does anyone else have that? So ICANN's the organization that's really managing that whole registry. So they're the Internet Corporation for Assigned Names and Numbers, and I've heard them described as a nonprofit and a not-for-profit. Sometimes there's subtle legal differences in that, and I saw it both ways on the ICANN website, so I can't really say specifically which they are, but they are an international organization that's sort of very democratic about how do we govern this space of the Internet. Okay? So they're in charge of approving the generic top-level domain registries. So people come, like VeriSign says, hey, I want to manage .com. So they have to go through an approval process with ICANN, and ICANN's like, okay, so we are going to give you control of the .com, and so people will ultimately come to you to reserve space inside of that GTLD. And then registrars, they get approved by the registry. I'm not entirely sure this is perfect, but this is the terminology I'm going to use. The registry is sort of that top-level space. So then someone like GoDaddy or Hover or Namecheap, any of these places to buy, where you would go and buy a domain name, like GoDaddy has to be approved by VeriSign to sell .coms, or by whoever owns the .net GTLD to sell .nets. So these guys, they work with often multiple GTLDs. If you go to GoDaddy, you can buy a .com, a .net, a .biz, a .info. You know, you can probably buy a .co, .mobi, .info. There's a lot that are available there. The business of trying to sort of make profit out of managing this process for you, so they want to make a lot of these available, and they want to upsell you on a lot, especially GoDaddy. So also Lifehacker here, the 5 best domain name registrars as kind of picked by Lifehacker's users. I think Hover topped that list. GoDaddy was not on that list, but they're the ones that, because they take Super Bowl ads, people have heard of. So that's what you do. You go to one of these registrars and you say, well, I want to buy redfinsolutions.com. So if I'm going to buy redfinsolutions.com through GoDaddy, they're going to manage the whole process with VeriSign and with the registry and making sure it's available, and they do that, and I pay them maybe $17 a year or something to have the privilege of owning that domain. One of the things that ICANN requires when you buy a domain is that you enter information into a public database. That's the WHOIS database. And you need to enter administrative contact information and technical details contact information into that registry. So a lot of times these places, this is a public registry, so you're putting your email address there, your address, your phone number, and so a lot of places, GoDaddy, will want to really try and upsell you on domain privacy. So basically what that means is they say, hey, we'll put some contact information in the public record, and we'll keep your private information private to us. And if you ever do like domain transfers, so let's say I registered my domain at GoDaddy. I don't like them anymore because he maybe shoots elephants, hypothetically, and I want to move that domain. Has anyone heard of this? He got in some hot water for posting videos of him hunting elephants, and there was like a mass exodus away from GoDaddy. I think Hover took the bulk of that, or Namecheap. Namecheap was had like a discount code, like elephants, and all the transfers that came in, they were giving like 50% of the profits to like elephants.com or something. They got a lot of business that way. So how did I get off on that tangent? If you want to transfer your domain name, so if you want to switch registrars, they will contact you at that administrative or technical contact information to say, hey, someone requested a transfer of this domain name. Is this okay? So that's why entering those, having real contact information at those administrative and technical contacts, especially the email address there, is very important if you ever want to do something with your domain name later, particularly transport. So talk about the WHOIS database, details, dragged on GoDaddy a good amount. Okay.
I will also figure out one of the things that so if you never the domain that you're registering, you can use that as your email. Because then if something goes wrong, you have that domain name.
Yes, that is a good idea. If you're registering, your companyname.com, you're better off putting a Gmail address as your technical contact, because if you screw up your DNS for where you're getting email at that domain name, you could be in some hot water. Good point. Okay, so now what? So we've gone and we've bought a domain name. So we've dealt with this sort of governance process, but we haven't really advanced into any actual DNS settings at this point, really. So what we really need here is a DNS host. What is DNS, the domain name system? It's a big phone book, and I think looking around that I'm not losing that analogy on people, but I think in a younger crowd people would say, phone book? Whitepages.com. So it's just a dictionary, it's just a directory. All it really is a name to number mapping. So if all the nodes that are connected to the internet in the world have a unique IP address on the public internet, we can't remember 172.13.64.12, or maybe we can, but we probably can't remember it for every website we want to visit. But Google.com, that's memorable. So that's what DNS exists for, is to simply translate names to numbers. But where is that dictionary stored? That's on a DNS host somewhere. And usually your registrar will also act as your DNS host. If you go to some of the super cheap like discount names and you get a domain name for like $3, they might not offer hosting. But there is free DNS hosting. Cloud DNS has a free option. I don't know if DNS Made Easy does, but DNS Made Easy has some really cool failover services and stuff too. So if they'll try to ping IP addresses, and you can set up so that if one fails, it'll take it out of the rotation and it'll go to another server. So it's sort of, DNS Made Easy has some good options for doing some kind of poor man's failover DNS based. But those are a couple of services that will act as DNS hosts. You can use them even if your registrar is doing DNS hosting for you, if you like the services that they provide. And we'll talk about sort of how that gets made happen. So let's remember, how does the internet work? How does this actually work? We have all these really private networks collected all around the world. Just like inside of my house, I've got a Mac and a laptop and an iPhone. No phones on this diagram. But eventually, let's say I'm this guy. I need to make a DNS request. I need to say, hey, what IP address is Google.com at? So I'm going to go out to the internet, and I'm going to find a DNS server. And for any network nerds that are here, DNS typically is going to run on TCP and UDP port 53, if that's of any interest to you. So we need to make a request from our computer to a DNS server to say, hey, what's the IP address of this place I'm trying to go to, Google.com, or whatever it is. So we have a client and a server, traditional client-server model. It's the same as the way the web works. We'll go ask for web on port 80 and we'll get HTML back. Here we're going to ask for a DNS record on port 53 and get that back. So that's a simple DNS request. So a very simple DNS request will go from your client to a DNS server somewhere on the internet. Now, since you need a DNS server in order to resolve names to numbers, DNS servers, you need to know the numbers of them. You need to know the actual IP address for the DNS server.
A question, if it gets off track, I don't know.
Sure.
So I just set up a wireless printer,
yeah,
which is not going the other way.
Yes.
Is there a relationship with DNS net, or is that a whole different conversation?
So that's actually what's interesting there is you could set up a DNS server inside your house so that you could use the name to number mapping for your printer. But usually there's not really any of that happening, so you kind of need to know the IP address of your printer. And DNS would help that inside your own little network. Okay. And some routers have little features of that built in. So a simple DNS request will go out. It doesn't have to go necessarily over the public internet. It could go to a DNS server that your company hosts and get the mapping right off that, or it could go over the public internet. Typically what this is a DNS server from your ISP. So when your cable modem talks to Comcast, let's just say, or Charter out here probably, some people have Charter. So when your router talks to that network, the Charter network, Charter says, okay, here's your IP address, here's your subnet mask, oh, and here are some DNS servers that you can use. Here are the IP addresses of Charter's DNS servers. So in a typical setup, the DNS servers that you're getting answers from are ones that your ISP has set up for you to use. But you can also change your DNS, which sometimes can get you into hot water or not. For example, JP's computer earlier was set up to get DNS from OpenDNS, but UMass won't let any requests outside of its network, so we had to rip that all out. But Google, the reason this Google one is super famous is because it's 8888. It's super easy to remember. So if you're ever in DNS hot water, you think you can't connect to a DNS server, that's one that you could try, and it's very memorable. OpenDNS is also another great free DNS server that's out there. But that's it. We ask for cisco.com and we get an public IP address back. That's simple. Incidentally, this is an A record request, type of request. So how does that phone book get populated over there at Charter? So Charter's domain name server, how does it know what the IP address is of google.com? So it's going to get a request. So I'm this little Charter ISP DNS server. I get a request for, let's say, google.com. So I might have that in my local dictionary already because someone else has requested it. And what I'm going to do is cache that record locally for as long as I'm told to have it. And that is the TTL, the time to live. So if you're ever setting up DNS records and you see TTL, that's what it is. How long can other guys cache and store this record?
Thank you.
So if I don't have it, nobody's ever asked for it before, or if it's past its time to live, so I cached it and it says keep it an hour and it's been an hour and 15 minutes, what I'm going to do is then that DNS server has what's called a forwarder. So I get this request and it goes upstream to somewhere else. And ultimately, that upstream is what we call a name server. So this is now where the client side is starting to connect to where you bought your domain name and you are setting up name servers. So when you buy your domain name, they're going to ask you, and they're probably going to disguise this in different speak, like park domains, and sometimes you see that. But what you're really trying to get at is, well, where are the name servers? When you specify the name servers with your registrar, you're saying, these are the guys who are the master record for where I want my domain's name-to-number mapping to be stored. These are the guys you should listen to. These are, I don't know if canonical is the right word, but that's kind of what I say. It's like, these are the authoritative records for what name-to-number mapping I want to store. Okay? So the name server can be either an IP address or another DNS name, like ns17.domaincontrol.net. That's a that points to a server somewhere that you're saying this guy is the authoritative record. So who do I ask if I don't know? That's really what if I'm just Charter ISP DNS, who do I ask if I don't know? I ask the name server. I want to get their authoritative record and then cache that one. So it might be the server from your registrar. So like GoDaddy will do DNS hosting for you. So it might be one of their servers. It might be from your web host. So sometimes you buy web hosting somewhere different than where you registered your domain name, and the web host will say, well, just set the name servers to us. So then they're the canonical record. And then, or it could be custom DNS hosts like Cloud DNS or DNS Mayday or whoever that is. So the domain records, there are different types of records that are stored in this dictionary. Again, more or less name-to-number mapping. And we've already talked about one type of record, the NS, or the name server record. So that's that particular record that says, who do I go to if I don't know? And there are others. So the domain host, Cloud DNS, your registrar, whoever it is, they provide the interface to all the records. and then you specify what routes where for your domain and everything below. So the first thing we hit are address records, and they all have, in parentheses, they're more often referred to by their short names, so we just call them A records. So the simplest record, it stores an IP address. You can only put an IP address in the sort of value, and it stores a name to a number. So your root record, let's say you own whybyfish.com. Okay? Your root record should always be an A record. It should always be directly to an IP address. That's just best practice. Some places won't let you not make it an IP address. Some people will, and you still probably shouldn't. I learned that because I was trying to do that, and then I was like, why won't it let me? And then I found best practice and blah, blah, blah. So, you can also store multiple A records for a single domain or subdomain. So this is a way to kind of do poor man's load balancing. So this is what we call round-robin DNS. So if you were to actually look up google.com, if you were to look at it with a NS lookup, which we'll do at the end, you'll see there's multiple IP addresses returned for google.com. And that's because the DNS server will give you one when you ask for it, but it'll give the next guy the next one. And every request that comes into it, it'll go round robin and just hand them out. So it's kind of a way to do load balancing based on DNS. So those are A records, very simple. CNAME records, they go sort of an extra hop. So the way that CNAME records work are, instead of saying give it an IP address, you give it another name. So you don't give it a number, you give it another name. So you might say that www, the subdomain, should be the same IP as whatever the root record is pointing at. So when I say root record, I mean whybyfish.com. The subdomain is www.whybyfish.com. So a subdomain is when you put one more thing before the dot, before your domain name. Those are subdomains, anything to the left of the domain you just purchased. So because it's hierarchical, remember, so when I buy whybyfish.com, I get that space inside of .com. Now I'm the master for whybyfish.com, so theoretically people could try and buy subdomains of that from me, you know, jerry.whybyfish.com and and.whybyfish.com. That's not usually how it works. You kind of just get yours and you deal with it yourself. I don't know anyone who's really selling subdomains unless it was like something very popular. Yeah, like email services you might pay to get something.hotmail.com or whatever. Yeah, that's a good example. So you might make www, the subdomain, a CNAME to @ is a symbol that usually means the root record, so whatever the whybyfish.com is. That means if someone types in www.whybyfish.com, it will give them ultimately the IP of the root record, except it does it in 2 steps, because first it resolves that, and then it resolves the one that it points to. And so you can get into sort of the con is there's a little bit of a DNS performance hit there the more CNAMEs you sort of layer in. It's enough to matter only on the initial request, because ultimately it's going to get cached, even on your local machine anyway, in your browser or whatever it is. Like if you look at Amazon Web Services, you'll find that there's sort of 3 or 4 levels of CNAME sometimes. And that's okay. And I think that those guys kind of know what they're doing. The pro is if you change your root record, then www doesn't need a change. You don't need to change the same thing in 2 places. You just need to change your IP address, and everything else kind of follows suit. So ease of administration versus performance, kind of the advantage to using CNAMEs. So MX records, these are your mail exchanger records. They're used for receiving email at your domain. So you'll set an MX record for typically not a subdomain, though you could do that. So typically you'll want to send email to john@whybyfish.com. The MX record says, where do I deliver mail that is addressed to anybody at whybyfish.com? The same rules apply. You can round robin it or whatever, but something else interesting about MX records is they also get a priority value assigned to them. Convention is kind of go 10, 20, 30, 40, 50, but they're just numbers in order. So when someone asks for MX records, they actually, the mail server that's asking for them will get all the records back in priority order, and they will try the first one. And if they can't connect to it, they will try one at the next level of priority. So lower numbers are more preferred. So 10 is going to be the first one that we try. 20, 30, 40, 50 is the last one we try will be in the 50s, or whatever the highest number is. And I'll show you that when we get into NS lookup. I'll show you how Google Mail. So, but that's what you need to know is the mail exchangers. Where do I send mail for this domain? Again, if you just get everything through, I keep saying GoDaddy. You don't have to certainly do it through them, but you know, GoDaddy will also say, hey, do you want the email service too for $17.95 a month for up to 10 addresses or whatever it is? They're just setting this for you and saying, hey, our servers at GoDaddy are going to receive mail for you. But if you get something like Google Apps for your domain, I think they just renamed that again. Google Apps for Business, yeah. They give you the MX records. They say, oh, you want to use our mail service, all you have to do is go and change your MX records, and here are the records that you need to set. So mail exchange records. Okay, pointer records. This is a little bit more advanced than like sort of typical web developer might encounter, but if you're running your own mail server that's going to send mail out, and so we do this at Redfin, we have a, we use dedicated server to do sort of shared hosting for our clients, and when we send mail out to another mail server from our web server, that other mail server, we have to say, we have to identify with it. And we say, hey, I'm redfinsolutions.com. I'm a server.redfinsolutions.com. Pointer records work the other way, and they're typically used by mail servers on the other side to verify that you are who you say you are. So these go in a little bit of a backwards order. So you set pointer records for domain names. No, you set pointer records for IP addresses and get back the domain name. It's a little bit different. So when I say to the mail server, hello, I'm redfinsolutions.com, okay, good. It looks at my IP address and it does a pointer lookup on my IP address, and if the pointer record says redfinsolutions.com, it will let it through. The reason they're doing this is to do spam prevention. So when Joe Schmo's server in some other country somewhere says, hey, I'm redfinsolutions.com, it goes and says, well, your IP address doesn't match the pointer record, so I'm not going to let this through. This seems like you're trying to assume someone else's identity. So that's what pointer records are largely used for in that case. The one you need to know is that they kind of work backwards. We're trying to put in a name, google.com, and get the IP address so we can route there. Pointers work the other way. Hey, okay, you say you're redfinsolutions.com, but you're giving me this IP address. Does the pointer record map back to who you say you are? Text records. These were originally invented sort of as a catch-all, just a way to store arbitrary text in a DNS record. Sometimes they were used for human-readable text. That was sort of early on. The trend now is to store machine-readable text in these text records. So email authentication and spam prevention, like SPF. Okay? That is the sender policy framework. That's a way that you can specify with your domain, hey, here are people who are allowed to send mail as this domain. So here are the IP addresses they're allowed to send mail as if it's from @redfinsolutions.com. And you put that in a text record. So when someone, like let's say Gmail spam filtering uses the SPF record in a soft way, not in a very hard way, but in a soft way to rank how likely it is that something is spam. So you get spam, and it says it's from PayPal.com. Is it really from PayPal.com? No. So what they do is they go to PayPal.com, they look up this DNS record, this text-based DNS record that's a sender policy framework. The SPF says only these IPs are allowed to send mail and say they're from PayPal.com, and your IP is not, so I'm going to bump up your likelihood of spam score. That's what sender policy framework does. I've also used text records for, and there's another way to do this, DKIM. I don't know a ton about it. DKIM, domain keys. It's
Mostly restricted to Yahoo nowadays.
yeah, Yahoo's the only guy I've ever heard of using.
The only major
DKIM.
player is still using
Yeah.
the SPF.
Oh, good. Because there was, when I first got into it, I kind of picked SPF on a coin toss, and I'm glad that one won. I did the same thing with VHS too. Right. And domain verification. This is another really easy way that I love to do domain verification, especially because we do a lot of work with clients, and our clients, sometimes they don't deal with this. We deal with this for them. I have access to their